Okay, here we are on the Incursion board game, and we're going to run a little design of experiment testing a game mechanic. In this case, how fast can the two sides come together and interact and combat each other. What we're going to look at is basically starting locations. So factor A is the lower number of starting locations, so each side is going to get one starting location. And the second factor is how far they are apart. In this case, we've counted out that they're 22 places apart from each other. So the low of this term is actually a further distance apart, and that's basically a transformation of factor B. Some assumptions that we're going to make is that we had 6 requisition points. So for the allies, that's going to be 2 of these apes. And for the SWD, we're going to take a Blitzhound and 3 Sturm Zombies as our forces. So we'll place out our forces. Another assumption we've made is that with command points, we've deemed that the allies go first. So starting off minus minus, we'll go take the apes, take their 3, they get 3 movement points. So we'll go 1, 2, 3, 1, 2, and changing direction, it counts as a point, so that's 3. And for the Sturm Zombies, it's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, and he has to stop, and then the Blitzhound comes in 1, 2, 3, and is stuck. So at this point, we're done with the turn. We have the number of spaces apart from each other, and that is 16 spaces. And the number of interactions, the second response variable we're measuring, is 0. They were not able to have any reactionary fire or attack each other. So this experiment, if replicated, would probably render, the way I play, it would probably render 3 conditions of the same results. Number of spaces apart from each other would be the same, and number of interactions would be 0, because all the line of sight is broken up by the structures here. So moving to another factor, B high, would put us at 4 spaces apart, and running that same experiment would put us at maybe the first ape would come in and he'd go 1, 2, 3. Second ape would come in, go 1, 2, and turn for 3. And at that point, his turn's done, but now he's in direct line of sight with this entry point. And every time SWD player moves, he'll have reactionary fire equal to 2 die. And for the Sturm Zombie, they have a health, they can only take 1 hit as long as I roll a 4 or higher. So he comes in, the first Sturm Zombie comes in for 1, we roll, and he survives it. 2, takes another step, gets shot at, dies. Next Sturm Zombie comes in, 1, gets killed instantly. Third Sturm Zombie comes in, survives first round, second round, third round's dead. Now the Blitzhound comes in, and he saw his buddies get killed, so he's going to be hopefully a little bit faster. He takes 1, 2, and takes a hit, so he has a damage token. He has 2 damage points, so he can keep going. 3, and he's dead. So at this point, collection of data is there's R2 is basically 1 space away from each other. They got a lot closer. The number of interactions, though, was counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for this Blitzhound. So we had 10 interactions in 1 space apart from each other. Rerunning that same experiment, and we'll just assume the allies did the exact same thing. The first Sturm Zombie comes in, is knocked off. Second one comes in, is knocked off. Third one comes in, is killed. Fourth, the Blitzhound comes in, takes a hit, goes a second step, gets killed. So now we have 2 spaces apart from each other, and we had 5 interactions. So that's a replicate of the same experiment with a different outcome. And the third time, if you want to be really good for statistical design, run everything 3 times. We get dead with 1 step. 1 step in, 2, dead. 1 step in, dead. And then finally, Blitzhound comes in, takes a hit, goes a second step, takes a hit. So that time, 2 spaces, 6 interactions. And so that's basic setup for the minus minus and the minus plus cases. We'll go one step further when it comes to plus and minus by adding more entry points. And for the SWD, we can place them in these locations. For a plus minus, again, there's going to be a lot of entry points, but they're going to be very far apart from each other. This one's 14 spaces, this is 16 spaces, and then for the plus plus, the only difference would be we're back to this spot, and they're very close together right here. So again, it gives us that variety of the experiments. You'll see the data and analysis in the PowerPoint.